Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. In this video, we'll show you how to do the gearbox as per the requirements for the computer aided engineering module. And we will be following the guides provided in these two PDFs, which you can find in the blackboards. Alright, this video will be divided into several parts for the duration. It might be a little bit lengthy, and the methods or whatever scientific method I'm using might not be the best or 100% true. It's all based on what I have learned in the college or from other videos on YouTube. Alright, so we'll need these two PDFs over here. One of them will have an examples, and the other one will have some inputs for our coursework, such as the input speed and the pressure angle, in addition to the materials that we'll need to use for each component, each part. One small note regarding the key. The key, we won't be able to change its material because it's an already it's a material we will be importing from a library with pre-built parameters. And for the second PDF, it has an example for a module of number 3, and each module will be different for each student, and each will have a certain numbers, such as the thickness of casing and the face width. For me, I'll be using in this example module number 2, which will have a thickness of 8 mm and a face width of 30 mm. Alright, in addition to this is an example of the case and the bearing cap. Alright, so before we start, you'll need to have a 2D sketch which we can use as a guide for our 3D model, and this is roughly what we are going to do. This is the 2D sketch of what we are going to do. The gearbox would have two gears. This is the shaft, the bearings, the bearing caps, and this is a sectional view. And over here we have a side view or front view according to how you design the 3D model. And we have almost all of the dimensions over here, and we'll be showing them according to our need. Whichever dimension we are going to need, we'll be showing, because there are a lot of dimensions, so we can't show them all together. It will be packed up. So for ease of view, you'll be only showing what we need when we need. Alright, and for the calculations that you need to do, you can find them here. These first five lines will have information that you can get from the blackboard. My module will be 2, and the number of pinion gear teeth will be 24, and the bigger gear will have 44 teeth, and the gear face width 30, and my case thickness will be 8 mm. These are the only calculations you're going to need to do. The rest of the dimensions will be either assumed, or you have to justify them or find any value that you find suitable for your design. So the first thing we'll need to calculate is the pinion pitch circle diameter, which is equal to the module into the number of the pinion teeth, which is 2 into 24 for my case, and the pinion outer diameter. We won't be using it, but you might as well calculate it. And the pinion shaft diameter, which will give us the diameter of the shaft that we're going to fix on this side. We'll be getting this diameter, and the rest diameters will be derived from the main diameter of this shaft. Alright, and the same case will be for the gear, the bigger one. So the same calculations will be repeated again for the gear pitch circle diameter and the outer diameter, in addition to the shaft diameter, which is the pitch circle diameter by 3. And this is this is according to our college. Alright, so for me it was 29.33 endlessly, so I rounded up to 30. And the center diameter will be equal to the pitch circle diameter of the pinion and the gear by 2 together. Alright, so we'll go to the inventor and start. it's better to keep one folder, which I kept it on the desktop, named Computer Aided Engineering Coursework 1 Gearbox folder. Here we have the 2D sketch, and here we'll be putting our inventor files, and over here the calculations and other documents we're going to need. Alright, so we're going to create a new assembly. Make sure that's metric, standard, millimeter, create. Alright, it will take some time. After the file is loaded, we'll go to file, save as, and give it a name. Alright, just make sure you choose the correct folder, 3D model. We'll call it Gearbox Assembly. Alright, save. Alright, so this is our empty assembly file, our new assembly file. Just to give you a brief idea of what we're going to do, there is already one that I pre-built before. This will be the final look of our gearbox. As you can see, we have the bearing cap over here for both gears. We have the bolts over here, and this is the case, and this is our case cover. Alright, and I'm going to disable this one so we can see the internal of our gearbox. Of course, it's functional. If we hold the shaft and we rotate it, it will rotate, and currently they are not overlapping, so the gears rotate just fine. Alright. So this is what we are going to do. Alright, so I close this one. No. Alright, so to start with, we're going to create our case. So we choose over here the browse template icon button, then we go to metric tab, we choose standard millimeter part file, not assembly but part file. We click OK, we give it a name, case cover, or we start by the case. So click OK, then we will click on any place on the working space. After that, we'll go to sketch and we click on rectangle. We can choose any plane, but it's better to go with XY plane. So we'll draw any rectangle over here, then we're going to give it the dimensions. Our dimensions are going to be according to here. We need the case dimensions, so we make that visible. Alright, so we have the width is 144. Alright, so 144. We adjust the view. Then over here it's 202. Again, adjust the view. We can check our 2D sketch. 242 with the base. We're not going to do the base right now, so we'll subtract 40 from this value. Alright, so we finish the sketch. Then we go to 3D model and extrude it. Alright, we'll be extruding it with a width of 90. Sorry. 90. Alright, most of these values over here I've made them either assumptions or based on the one I built before, but the main dimensions you need to do or to know are these, and the rest will be assumed by you. Alright, so now we click on return. Okay, so this is the box that will be our case. So to extrude it and create the hollowness inside, to empty it from the inside, we will right click on it, we'll go back to editing mode, and then click on this surface and go for create sketch. Alright, we'll go and draw a normal rectangle inside of it. Adjust the view. We go for dimension. We want the dimension between each side and the opposite side from the original case box to be 8. which is the thickness that we want, or according to my module, which is 2. Alright, repeat the operation for all 4 sides. Alright, and then I'm going to add a circle. This circle give it diameter of 20. The use of this circle is to create a space or a place for the bolts to fit in. And then we're going to trim the unnecessary parts. Diameter of 20. The center of the circle will be on the intersection point between these two lines, or in the corner of the rectangle. Alright, now I'm going to trim them, the unnecessary parts. Alright. And then we can make a fillet with value of 1.5. You can choose according to your drawing. Alright. Sorry, I made a mistake over here. Control Z. Alright, so this is the fillet of 1.5. We'll make it 2. Alright, this seems better now. Alright, we'll do the same fillet for all these sides of the intersecting point between our arc and our rectangle sides. Alright, now we close the fillet and finish sketch. Then we go for extrude and choose cut operation. Then we have the width of our side. We can measure it right now by right click on the, wait a minute, I'll repeat it. Right click on the workspace, then go for measure and click on this corner over here, or this edge, and we have it as 90 millimeters. So the extrusion will be 90 millimeters minus 8, which is my thickness. So 82. Wait, I think I chose the wrong side or the wrong object. Alright, cancel it. I chose the wrong profile to extrude, so I need to pick this one, the inner object, and click OK. So now we have our case. Seems nice. Alright, so now we're going to select this side or this surface and click on it. Then we go for create a new sketch. We will create the mounting holes for our bolts. Alright, so the holes can have a diameter of, let me check the sketch if I have them over here. Circular objects, dimensions. So I have them as 12. Alright, so 12 it is. So 12 kind of seems a little bit big, so I may reduce it to, let's say, 8 for example. 8 seems fine. Alright, so 8. The dimension from here to here. Alright, so we can't add it. Alright, because it is resting on the center of the arc. So if I deleted it and place it somewhere else, say 8, and then the dimension from this side to this side, if I put it as 8, and from here the center of the circle to this side as 8. So seems that if it was resting on the arc side, it was kind of better. So 8, and just to check the dimensions, it is 8, we accept it. So now we can't control the dimensions, it's just displaying the current dimension, which is 8 by 8, which is nice. Alright, so we'll repeat the same process for all the corners. Alright, so yeah, they all are the same line. Eight, and the last one. Alright, 8. So this seems okay. So we finish the sketch, then go to 3D model, then extrude. Choose the holes. Make sure that you don't choose any wrong object. Then go for cut. And for the cut, the, the depth of the cut, we can 30 seems nice. Alright, we'll go by 30. So now we have the case almost ready. So we hit return, then click save and click OK. After that we'll be creating our case cover. So go to create, choose the template, metric, standard, OK, and give it a name. We'll call it case cover and OK. Then we click on any place on the working space. After that we go to sketch, we choose rectangle, we go for XY plane, we draw any rectangle from the origin point, then we go for dimension. It was 144. It's really important to know your dimensions, and over here is 202. Finish sketch, we will extrude it. Alright, the extrusion will be 8mm, which is the thickness of my case. Alright, I'll just adjust the view, and then I will click on this surface and create a new sketch, and over here I'll be doing the same mounting holes for my bolts. And as we remember, it was diameter of 8mm, and the dimension from both sides were 8mm and 8mm. And then I will be repeating the same process. 8, and the dimension from both sides are 8mm. Alright, last two corners. Go for dimension 8, from the center to the side 8, alright. Now click on finish sketch, go for extrude, and click on the 4 mounting holes. Alright, I made a mistake again, sorry, I misclicked that again. It's better to zoom in. Alright, and choose cut. This should cut through, right through our case. We'll just put 10 for safety purposes. Alright, so we have our case cover ready. So click on return, go for a proper view. Alright, now we're going to constrain our case cover. So go for constrain, choose the flush solution, then click on this side, over here, this side with this side, so they'll be aligned together, and hit apply. After that go for this side and this one, click OK. So now the our case cover is well aligned to our case, but now we won't close them together. We'll keep it like this. After, when needed, we'll be mounting them together or fixing them together. Alright, I will continue in the next second part, the adding of gears and other components. Alright, thank you.